Welcome back to Refreshing Careers. Today we are going to do the part 8 of linear programming, and today we'll be solving the equation based on simplex method. So the question for today is, in a car assembling center, three models of car, that is A, B and C, are assembled. The cars once assembled in this center are tested before being sent to showrooms for selling. Model A requires 4 hours in assembling and 5 hours in testing. Model B requires 5 hours in assembling and 4 hours in testing. Model C requires 4 hours in assembling and 4 hours in testing. The car center has a maximum of 80 hours for assembling and 100 hours for testing. The total number of cars that can be assembled and tested every day cannot exceed 20. The unit profit from Model A is Rs 7,000, from Model B is Rs 10,000 and from Model C is Rs 8,000. How many cars of each model should be assembled and tested for maximum profit? So here they are clearly asking us to find out the number of cars. So the question itself, they are saying clearly that we need to find the number of cars that has to be produced, that has to be assembled and tested, so that we get the maximum profit. So what's our objective here? Objective is very clear. They're saying that objective is of getting maximum profit. And how do we get it? By the sale of cars. Okay, by assembling and testing the cars. So how many cars should be assembled and tested is what we need to figure out. Before that, we need to know that what is the profit you're going to get per unit of car, which is mentioned in this sentence. The sentence says that on car A you are going to get a profit of Rs 7,000. On car B you are going to get a profit of 10,000, and on car C you are going to get a profit of 8,000. So based on this information, based on last two sentences, we will be formulating our objective functions first. Here the objective is to maximize profit from the sale of cars as mentioned in the question. Let us assume that the total profit is Z. We don't know the total profit. That's not given. That is what we need to figure out. We need to find out the number of cars through which you are going to get the total profit. So what is the total profit? We don't know. So we are assuming it to be as Z. The total profit will be equal to profit from Model A plus profit from Model B plus profit from Model C. Your total profit will be equal to how much ever profit you are going to get by selling the car A. The total profit you are going to get by selling all the cars of B type, and all the profits you are going to get by selling all the cars of C type. So when you add all these three, then you are going to get a total profit. So how much profit are you going to make from Model A? The profit that you are going to make from Model A will be equal to the total cars of Model A that you are going to sell. Okay, the total cars of Model A that you are going to sell multiplied by price per car. Price or profit would be the better word. Profit per car of Model A plus total cars of Model B. Total cars of Model B into profit per car of Model B. Total cars of Model C into price, it will be profit. Profit per car of Model C. So that is what your total profit is. Okay, your total profit will be equal to, this is profit. Profit per car of Model A, this again is profit per, and see all the profit per car of Model A, Model B and Model C are given in the question. As we read, profit per unit is given, but they have not given us what are the quantities of the cars that we have to produce, because that is what we need to find out. So we don't know what is this total cars of Model A, total cars of Model B and total cars of Model C. So we will be replacing this by x1, x2 and x3. X1 will be your total cars of Model A, X2 will be the total cars of Model B, X3 will be the total cars of Model C. So we are going to assume this and this as x1, x2, x3, which are your decision variables, and then we will be multiplying it with the profit per car of Model A, profit per car of Model B and profit per car of Model C, which is given here. 7,000, 10,000, 8,000 is the profit per unit for all these models. By replacing this in the statement, you'll get that total profit is replaced by Z. Okay, total cost from X1 is the total cost from model A multiplied by 7,000 is the profit per car of model A plus X2, which is the total cost of model B multiplied by profit per car of model B, that is 10,000, plus total cost of model C, that is X3, multiplied by 8,000, which is the profit per car of model C. That's how you'll get the linear equation. That's how you're going to get this linear equation. So this is your linear equation. So you have to maximize Z, and the equation is what you have written below. This is your equation. Now the next thing which you need to find out is our constraints. In this question there are three constraints. Okay, there are three constraints. We need to figure out those constraints. The first constraint is the car center has a maximum of 80 hours for assembling. For assembling, it has maximum 80 hours and 100 hours for testing. Okay, 80 hours for assembling, so it is a maximum of 80 hours and 100 hours. Okay, 80 hours for testing, 100 hours for assembling. 80 hours for testing and 80 hours for assembling and 100 hours for testing. Okay, I wrote the other way around. 100 for testing. Okay, 100 for testing, 80 for assembling. So this is the information they have given. First, let's form a constraint with regards to 80 hours. The car center has a maximum of 80 hours. Okay, if it has maximum of 80 hours for assembling, with respect to assembling cars, the unit has only 80 hours and this is the maximum. So it can be either equal to 80 hours or it can be anything less than 80 hours. That is what they are saying. So assembling for model A, if you want to assemble a car of model A, it will require you 4 hours. If you want to assemble a car of model B, it will require you 5 hours. If you want to assemble a car of model C, it will require you 4 hours. And totally how many hours we need, we are having to assemble, that is 80 hours. In our hand we are having maximum 80 hours. So we can assemble, the total hours for assembling can be either equal to 80 hours or can be less than 80 hours. So keeping these and this in mind, let us formulate the constraint. Equation with regard to constraint. The first equation will be 4x1 plus 5x2, 4x1 plus 5x2 plus 4x3 plus 4x3 less than equal to 80. And our next sentence says, this is respect to testing, and 100 hours for testing, maximum of 100 hours for testing. And for testing model A we require 5 hours. Okay, test a car of model A we require 5 hours. To test a car of model B we require 4 hours. To test a car of model C we require 4 hours. So this is hours we require to test the car of model A, B and C. For per car testing, this is the time that it is taking, and the total and the maximum hours in our hand is 100 hours. So it can be equal to this total of whatever this is going to be, 5x1 plus 4x2 plus 4x1, that's the total, has to be either equal to 100 or it has to be less than 100, because they have said it's maximum 100 hours. Okay, let's formulate the constraint. 5x1 plus 4x2 plus 4x3 less than equal to 100. So here basically what we are saying is, this is with regards to assembling, this is with regards to testing, and this is the hours. 4 hours for x1 units of A, 5 hours for x2 units of B, 4 hours for x3 units of C. With regards to assembling, this is the total time. This will be the total time, that is this actual total time for assembling, which will be either equal to 80 or less than 80. That's what we have been informed. So we have formulated it in this way as an inequality. Now the next constraint is this. In this is with regards to testing. You require 5 hours for testing x1 cars, okay, cars of A1. You require 4 hours for testing x2 cars of model B. You require 4 hours for testing x3 model of car C. Okay, and this is the total time, this is the total actual time for testing, and this total actual time for testing should be either equal to 100 or should be less than 100, because they have said that it has to be a maximum 100. That's how we got these two constraints. Now the third constraint. There is a third constraint, that is this. The total number of cars that can be assembled and tested every day cannot exceed 20. So in a day, the maximum cars that they can assemble and test is 20. It will not exceed 20. Either it is going to be equal to 20 or it will be less than 20. So your total cars per day won't exceed 20 is what they told. That is, this is the easiest one. x1 plus x2 plus x3. x1, x2 plus x3 will be less than 2 or equal to 20. That is the total cars. Car A plus car B, total of car A plus total of car B plus total of car C will be either equal to 20 or it will less than 20, because they said in in a day maximum that we can produce is only 20 cars. Assemble and test is only 20 cars. That's how we got this equation. Okay. Now next is the non-negativity condition. Here x1, x2 and x3, x1, x2 and x3 can be positive, can be 0, but will not be negative. Because the number of cars, because see, x1, x2 and x3 represents, x1, x2 and x3 represents the total cars of model A, total cars of model B and total cars of model C. Okay, x1, x2, x3 represents this. So when you're producing something, the total cars can be a positive number or it can be 0. 0 meaning no production. But how can it be negative? You can't produce negative cars, right? So that's why it has been said that this can be positive, this can be 0, but it cannot be negative. Okay, that's why we have used this symbol, greater than or equal to. So x1 is greater than or equal to 0, x2 is greater than or equal to 0, x3 is greater than or equal to 0. Now let's write everything down. Your Z is equal to 7,000 x1 plus 10,000 x2 plus 8,000 x3. 8,000 x3 subject to subject to 4x1 plus 5x2 plus 4x3 less than equal to 80, 5x1 plus 4x2 plus 4x3 less than equal to 100. These are the constraints. The last constraint is x1 plus x2 plus x3 greater than or equal to 20. And then our non-negativity condition, that is your x1 is then equal to 0, x2 is equal to 0, x3 is then equal to 0. The next step is to do augmentation. Augmentation refers to converting all the inequalities into linear equation by adding slack variables. Inequalities refers to lesser than sign or greater than sign. So all these are inequalities. When you write like this or like this, that is greater than, equal to, less than, equal to, all these become these are called as inequalities, and these inequalities have to be converted into linear equation to solve it further. Okay, and to convert into a linear equation, you need to add slack variables. To convert inequalities to linear equations, slack variables have to be added. Now, what is slack variables would be the next question. Let's take some equation. So, this is one equation, 4x1 plus 5x2 plus 4x3 less than equal to 80. If this entire thing was equal to 80, then we can understand that all the resources are being fully utilized. Okay, you can understand that all the resources are fully being utilized. But here what is happening? It can be either what if it is less than 80? What if it is just 4x1 plus 5x2 plus 4x3 less than 80? Less than 80 means some resources would be left out. Some raw materials would not be used. Something would be left out, right? Because complete utilization is not happening. So slack variable is that that amount of raw material, or that amount of the input which is not being utilized, that is just left out, that is being waste. That means you have used this maybe if you consider this as an input, all these three as an input, after utilization of all this input, if something is left out, that is represented by your slack variable. That is represented by your slack variable. That's why we'll be using slack variables to convert it into linear equation. Okay, linear equation means this is a linear equation. Z is equal to 7, wherein there is an equal to sign. So this thing is called as linear equation. Here this is not a linear equation because there is less than equal to sign. So this is an inequality. It has to be converted to linear equation. To convert it, we'll be adding a slack variable. So what if it is equal to 80? If it is equal to 80, slack variable will be equal to 0. That's what it is. If it is equal to 80, slack variable will be equal to 0. If it is less than 80, then that extra raw material that's left out, or the input that is left out, which is not been utilized in the production of all this, that extra amount would be represented by the slack variable that you have to put. We would assume something to be a slack variable and add in all these three inequalities so that we can make it a linear equation. So we need to add slack variable in this, then another slack variable in this, another slack variable in this. Only then it will become a linear equation. Now let me do that. So the constraints after augmentation will be as follows: 4x1 plus 5x2 plus 4x3 plus s1. This is your slack variable is equal to 80. This is the same equation. I have just added s1 in this equation. Similarly to this equation, I will be adding s2. 5x1 plus 4x2 plus 4x3 plus s2 is equal to 100. Okay. And the last one is x1 plus x2 plus x3 plus s3. This also is a slack variable is equal to 20. This is the same equation. I am just adding one slack variable. And all of these variables, x1, x2, x3 and all the slack variables will be greater than or equal to 0. Will be greater than or equal to 0. That's the this is the non-negativity condition, and all these are the constraints. All these are the constraints after augmentation. And what is augmentation? Augmentation is when you are converting all the inequalities into linear equation, and that is done by adding slack variables. That is what you have done here, and this is the constraints after augmentation. The next thing we need to do after this is we need to change the objective function. Here we are not changing the objective function completely. Objective function remains the same. What you're doing is you're just adding the slack variables. And when adding the slack variables also, you're making sure that the coefficients of the slack variables are 0. If it is 0 means 0 into S1 is nothing but 0. 0 into S2 is 0. 0 into S3 is 0. So this presence of this or absence of this is the same, right? It doesn't make difference. So 0 S1 being there or not being there is same. So basically the objective function is Z is equal to 7000 x1 plus 10,000 x2 plus 8,000 x3 itself. We have just added these three. And why we have added these three when it is not actually needed? It is being added because all the variables that is there in the constraints, all the variables present in the constraints should also be present over here. All the variables present over here in the constraints have to be present even in your objective function. And here x1 is there, x2 is there, x3 is there, but s1, s2, s3 which are present in your constraint is not present in your objective function, and that is the only reason we are adding it. And we are adding it here because for solving using this particular method, it is essential that all the variables in the constraints are part of the objective function, and hence we have added this 0s1, 0s2, 0s3. But what you need to keep in mind is this has not changed the objective function at all. It has just remained the same. We have just added something which is absent even though it is present. Once we are done with this step, we need to find out the initial basic feasible solution. We need to find out the initial basic feasible solution. To find that, we need to assume certain values to be equal to zeros. So basically what you need to understand here is, there are how many variables? Totally the number of variables is 6. There are 6 variables. And those 6 variables are, there are 6 variables, which is x1, x2, x3, s1, s2, s3. These are your 6 variables. Okay, these are your 6 variables. So the number of variables that you're having is 6 totally in the entire equation, whatever you have formed. Okay, entire thing, in everything, how many variables you're having is 6 variables, which are these. Okay, so your number of variables is 6. In this, what you need to do is, to find the initial basic feasible solution, we need to consider some of the variables. Okay, out of this 6. Okay, out of these 6, some of these we have to consider it to be as 0. Some has to be zeros, and some has to be equal to 0, and for some we need to give some values. Okay, we need to give, it's basically like trial and error method. We are just trying out with some value first. If it doesn't work out, we are going to try with something else to reach the optimal solution. So first thing which you need to do is, out of all these things, we have to assign values. Now we have to assign certain values which might give us an optimal solution, which might not give us an optimal solution. That we don't know, that we'll find out later. So now our task is to assign the values. So now, for out of all the 6 variables, for which variables should we assign the value as 0, and for which we should assign some other numerical. How to find that out is by using this simple logic. This is a logic that is used to find it out. Number of variables minus number of equations will give you the number of variables to be equated as 0. How many equations you have? Total you have 1, 2 and 3. You have 3 equations. This is your non-negativity constraint. So this will not be considered. Only these 3 things will be considered. Objective function will also not be considered. Only your constraints will be considered. So these 3 equations will be considered. So the total number of equations is 1, 2 and 3. So total you have 3 equations. So number of variables is 6. Number of equations is 3. So number of variables to be equated as 0 will be equal to 6 minus 3, that is 3. I'll explain this again because this will get little confusing as we move ahead. The number of variables, okay, the number of variables is 6. That is, these are the 6 variables. Number of equations is 3. 1, 2, 3. And we'll consider only the constraints. We will not be considering the objective function equation. This equation will not be considered. Only these equations, only the constraints will be considered, and this is not an equation. This will not be considered because this is a non-negativity constraint. This won't be considered, and objective function won't be considered. Only this constraint will be considered, and there are 3 constraints. That's why we have done 6 minus 3, that's equal to 3. So by this 3, what we understand, that means there are 3 such variables. Out of these 6 variables, for 3 variables we can assign the value as 0. For 3 variables we can assign the value as 0. And those 3 variables which I am assigning the value as 0 are x1, x2 and x3. So basically I am putting x1, x2 and x3 as 0. because any three variables I'll have to consider it as 0. So I made these three equal to 0, and then see, once I assume that x1 is equal to 0, x2 is equal to 0, x3 is equal to 0, I can put it in the constraint equation. This is the equation for the constraint: 4x1 plus 5x2 plus 4x3 plus s1 is equal to 80. We know that x1 is equal to 0 because we have assumed it to be as 0, x2 is equal to 0, x3 is equal to 0. So 4 into 0 is equal to 0, plus 5 into 0 is 0, plus 4 into 0 is 0, because all these three, x1, x2, x3, all are 0, plus s1 is equal to 80. So basically s1 is equal to 80. Similarly, when you solve all these things, you will get s2 as 100. Similarly, when you solve this, you will get s3 as 20. How are you doing this? We are doing this from this. Okay, from basically, since we assumed that x1 is equal to 0, x2 is equal to x3 is equal to 0, since we have assumed all these three to be equal to 0, we will be putting this in the constraint equation that we formed previously. Once we put x1 value, x2, x3 values, that is what you assumed here. When you put it once in the equation, you will get your s1 is equal to 80, your s2 is equal to 100, and your s3 is equal to 20. So this is your feasible solution. So the initial feasible solution is s1 is equal to 80, s2 is equal to 100, s3 is equal to 20. This is not the optimal solution still. We don't know whether it is optimal solution or whether it is not optimal solution. We have no idea still. But we are going to assume this as optimal solution. We'll just consider, not optimal basically, we'll consider this as one of the feasible or possible solution. This could be the solution. So to confirm whether it's optimal solution or not, we need to use a table. That's what we'll be doing next. But in this stage, what we found out, the thing that we found out was, that the initial basic feasible solution is, s1 is equal to 80, s2 is equal to 100, and s3 is equal to 20. So this is the initial basic feasible solution. Now based on this, we will be solving the question. So this step 2 is to just find out the feasible solution, and the feasible solution is s1 is equal to 80, s2 is equal to 100, s3 is equal to 20. We got the solution when we assumed x1, x2 and x3 to be equal to 0. And why we assume this to be equal to 0? Because as per our logic that we used, they have told that we need to subtract number of variables minus the number of equations to get the number of variables that has to be assumed to be 0. So they have told any 3 variables has to be assumed as 0. Totally we have 6 variables. Out of this, any 3 we can assume as 0. So I assumed x1, x2 and x3 to be as 0. That's why this has been taken as 0. When I took this as 0, I got these values. And this is my feasible solution, and this is what we need to find in the step 2. So once we have done the initial basic feasible solution, we need to go to the step 3, in which we will have to create a table. Okay, so this is the initial simplex table. So in the initial simplex table, the first thing that we will be mentioning is the basic variables, and the basic variables are s1, s2 and s3. Okay, basic variables are the variables for which basically you have solutions. That is, here we have found out solution for s1, s2, s3. So they will consider that to be our basic variables. So basic variables are s1, s2 and s3. Now over here we will be writing all the variables that are available. All the variables that are available should be written over here. What are the variables that are available? x1, x2, s3, s1, s2, s3. So all that we will have to mention here now. Now we have mentioned all these variables, that is all the 6 variables have been mentioned. So first we will be mentioning the basic variables, then we will be mentioning all the variables, then we will be mentioning all the variables that we have in our question. Okay, so the basic variables are s1, s2, s3 that were mentioned here. And then in the other columns the headings are these. Now next thing that we need to do is mention what is all this equal to. See, S1, S2, S3 is equal to what? X1, X2, X3, S1, S2, S3. All these things is equal to what? To find what it is equal to, we need to refer to the objective function. We need to refer to the objective function. Let me copy this. I'll just put it over here for reference. Now we have to see the objective function. Okay, what is the coefficient of x1? Coefficient of x1 is 7000. Coefficient of x1 is 7000. So we'll be writing x1 is equal to. So we'll be writing x1 is equal to 7000. x1 is equal to 7000. Why am I writing this? I'm writing this because the coefficient is being given as 7000. Okay. Now similarly, what's the coefficient of x2? The coefficient of x2 in the objective function is 10,000. So here we'll be writing x2 is equal to 10,000. x2 is equal to 10,000. Okay. So we wrote what is x2 equal to. Similarly, x3 is equal to what? x3, the coefficient of x3 is equal to 8,000. The coefficient of x3 is equal to 8,000. Okay, so we got the value of x1, x2 and x3, that is 7,000, 10,000 and 8,000. The next thing is s1. What is s1 equal to? s1 is equal to 0. s1 is equal to 0. Similarly, we have to do for everything. Okay, so now I've done the same for everything. I've just mentioned the coefficients of everything. Okay, as per the objective function. We need to take the objective function and we have to write down what everything is equal to. x1 is equal to 7,000. We are writing this for reference. Okay, we need not write all the 7,000, 10,000, 8,000. Writing all these values so that there will be little more clarity while solving. Okay, so x1 is equal to 7,000, x2. So these are the coefficients. Similarly, these are the coefficients, and we found this through the objective function. Okay, so the objective function. And now the next thing that we have to do is we found another thing, that is the initial basic feasible solution. The initial basic feasible solution will be in the next column. That will be represented by bj. That will be represented by bi. Okay, this will be represented by bi. This is nothing but a basic feasible solution. Okay, that is 80, 120. 80, 120. So I have filled this column. bi is nothing but your initial feasible solution 80, 120. 80, 120. So x1 is equal to 80. That is what we are assuming. S2 is equal to 100, S3 is equal to 20. This is what we are assuming and solving this entire thing. So our base assumption, we are going to write bi is equal to all these three. Now we have to fill in these values. Okay, now the next thing which we have done is we have placed all these values over here. The next question will be, how did we get all these values? We got all these values from the constraints. That is, this is the first constraint, right? 4x1 plus 5x2 plus 4x3 plus 1s1 plus 0s2 plus 0s3 is equal to 80. That is what is the first constraint. 4x1 plus 5x2 plus 4s3 plus 1s1 plus 0s2 plus 0s3. 0 I have not mentioned 0s2, 0s3, but since that values have not been there, we can include it by just putting 0 as the coefficient. We can include s2 and s3 by putting it as coefficient. So the coefficient of x1 is 4, the coefficient of x2 is 5, the coefficient of x1 is 4, x1, so in the x1 column you are writing 4, the coefficient of x2 is 5, the coefficient of x3 is 4, the coefficient of s3 is 4, the coefficient of s1 is 1, the coefficient of s1 is 1, and s2 and s3 are not there in the first constraint. So we will be taking it as 0. If you put 0 as coefficient, 0 s2 is nothing but 0. So if you put it as 0, it's not going to change the equation. So you can put this as 0. Similarly, you can put this as 0 as it's not going to change the equation. So that's how we got all these values. Similarly, all these values have been derived from the second constraint, 5x1. So x1's coefficient is 5, thus 5. x2's coefficient is 4, thus 4. x3's coefficient is 4, thus 4 here. s2's coefficient is 1, s2's coefficient is 1. S1 and S3 are not there for the second constraint. It's not there for the second constraint. Hence, we are putting it as 0 here and 0 over here. We are considering the coefficient of S1 and S3 in the second constraint to be equal to 0, because 0 S1 and 0 S3 will be equal to 0 itself. Right? Since those two variables are not mentioned in the question, we can put the coefficients and 0 and write this down as 0, 0, because it's not going to change the equation. Similarly, we did this. Coefficient of x1 is 1, coefficient of x2 is 1, coefficient of x3 is 1, coefficient of s3 is 1. So coefficient of s3 is 1, coefficient of x1 is 1, coefficient of x2 is 1, coefficient of x3 is 1, coefficient of s3 is 1. S1 and S2 is not mentioned for the third equation, thus we will be putting 0. We will be considering the coefficient to be 0 and we are putting this as 0. That's why it is 0, 0. So that's how we got the values. That's how we got the values. This column. This column is the feasible solution that we found over here, is the initial basic feasible solution. This column, what we got, represents this column, whatever written the value 7,000, 10,000, 8,000, this we have got from the objective function. These are the coefficients. Coefficients as per the objective function. This also is the coefficients as per the objective function. And why we have written this in the row column, S1, S2, S3? Why we have put the heading of row column? Because these are the basic variables. Because we found out that S1 is equal to 80, S2 is equal to 100, S3 is equal to 20. So that's why we are putting S1, S2, S3 over here. And we have put it as 0, 0, 0 because all these figures we have derived from the objective function. All these figures are derived from the objective function and these figures we derived from the constraints. Now the next row that we have to do is Zj minus Cj. Zj minus Cj. Now what is Cj? Let me say what is Cj first. Cj is nothing but the coefficients of all your headings of the column. So these are your columns. So these are the headings of the columns. Here whatever coefficients you have, the coefficient of x1 is 7,000, the coefficient of x2 is 10,000. So all these coefficients, 7,000, 10,000, 8,000, 0, 0, 0, all these things would be Cj. Okay, all these things would be the Cj. Okay, and then Zj would be whatever numerical you are considering, that numerical multiplied by your coefficient of what is present over here. Okay, whatever numerical you are taking multiplied by coefficient of whatever is mentioned over here. So basically, let me take any row. So Zj for 4, Zj for this numerical, Zj for this particular cell is 4 into 0. Why did I take 0? 0 I took because we have considered S1 to be equal to 0. Okay, so 4 into 0, we get 0. So Zj value here is 0. Zj value for this. What is Zj value for this? Here the cell value is 0. The cell value here is 0. This 0 multiplied by 0 will give you 0. So Zj value is 0. Zj value for 5. Zj value for 5 is equal to 5 into 0, that is 0. So Zj here for 5 is, for this particular cell is 0. Zj value for this is 4 into 0, 0. Zj value for this is 1 into 0, that is 0. Zj value for this is 0 into 0, which is 0. Zj value for this cell is 0 into 0, which is 0. Zj value for 5 is 5 into this 0, which is 0. Zj value for this is 4 into this 0, 0. Similarly, we will have to find the Zj values of all multiplied by the Cj value for the respective cell. Now we will do for the first one so that there is more clarity. You will understand it better when you do it. So here it is 4 zj is for this particular thing. Now we are doing only for this. Zj for this particular cell is 4 into 0, that is 0. 4 into 0 is 0. 5 into 0 is 0. 1 into 0 is 0. Okay, 4 into 0 plus 5 into 0 plus 1 into 0 minus your Cj. Cj is 7000. So your answer here would be minus 7000. So your answer here would be minus 7000. So the answer here it would be minus 7000. How did I get this? See, first thing which you need to calculate is the summation of the zj's. Okay, you have to not just take one zj. You have to find the zj of this, zj of this, zj of this, and then you have to take a summation of this. Then you will get the total zj. Once you get the total zj, you have to subtract it with 7000. You have to take the total of the zj minus you have to subtract with whatever you have over here, your coefficient of x1 will get minus 7000. That's how I got 7000. I did 4 into 0 plus 5 into 0 plus 1 into 0 minus 7000. Okay, that's how I got minus 7000. Similarly for these values we need to find the zj minus cj. Zj will be 5 into 0, that is 0, plus 4 into 0, that is 0, plus 1 into 0, that is 0, minus cj, that is 10,000. So here you will get minus 10,000. So your answer here would be minus 10,000. That's how I got minus 10,000 here. Now similarly you have to do for this. 4 into 0 is 0, plus 4 into 0 is equal to 0, plus 1 into 0 is equal to 0, minus 8,000. So here your answer will be minus 8,000. Your answer will be minus 8,000. Zj minus cj is equal to minus 8,000. Okay, that's how we got this. Now similarly you have to do for all these things. 1 into 0 plus 0 into 0 plus 0 into 0 minus 0 is equal to 0. That's how we get a 0 over here. So we get a 0 over here. 0. Similarly we'll get 0 over here. Similarly we are going to get 0 over here also. Let me show you how. 0 into 0 0 plus 1 into 0 0 plus 0 into 0 0 minus 0 cj, that is 0. You will get a 0. Similarly for this, 0 into 0 0 plus 0 into 0 0 plus 1 into 0 0 minus 0, cj is 0, so 0. So that's how you got 0 over here. That is how you got all these values. That's how you got the values minus 7,000, minus 10,000, minus 8,000, 0 0 0. So once you got all these values, now we have to see whether the solution is optimal or not. See, to know whether these solutions 80, 100 and 20, to know whether these solutions are optimal, we need to see these zj minus cj values. It has to be either 0, all these values, okay, this entire row that we are seeing over here, this entire row values has to be, either equal to 0 or it has to be a positive number. It should not be a negative number. Okay, it should be either a positive number or 0. But here we can see 3 negative numbers. That means these 3 are not the feasible solution. That means these 3 which we considered as feasible solution are not the feasible solution which we found out by solving this. By this table we found out that this is not the feasible solution. So once we came to know that this is not a feasible solution because we got a negative number as zj minus cj, now that's why we need to again solve it. Okay, again solve it. I'll be saying how. Before we go to the next table, you have to create another table. Before we go to the next table, in this particular table, we have to recognize the pivot table. We have to recognize the pivot column. We have to recognize the pivot column. So basically you have 1, 2, 3, 6 columns is what we are having. You have to recognize the pivot column. Out of all these 6 columns, which is the pivot column? Okay, pivot column is that column which has the least value. Okay, it has the least value. And amongst all this, the least value is minus 10,000. Okay, the least value is minus 10,000. So this is your pivot table. This is your pivot. This is your pivot column. So this is your pivot column. So this is your pivot column. So this becomes your pivot column. So now we came to know that this is a pivot column. So this particular column becomes very important. Okay, this column is very important because based on this we have to do the next step. The next step is we have to divide the bi by x2. Okay, we have to divide bi by x2. Why are we doing that? We are dividing bi by x2 so that we get some other numbers through which we can find out the departing row. Because next step is to find out the departing row. To find out the departing row, we need to divide b1 by the pivot column. We need to divide b1 by the pivot column, and this is the pivot column. That's what I'll be doing in this particular column. I'll be dividing it. See, now I have taken this as bi divided by x2. Bi is this. This is a feasible solution, which is not the feasible solution. We assume this to be the feasible solution, but this is not the feasible solution. So we'll be dividing bi divided by the pivot column. That is this. Okay, so pivot column, the values are 5, 4 and 1. So 80 divided by 5 is 16. 100 divided by 4 is 25. 20 divided by 1 is 20. That's how we got all these values. Now out of these figures, which is the least? Out of all these figures, the least is 16. 16 is the least. Okay, so since 16 is the least value, this entire row will be called as the departing row. This entire row will be called as the departing row. So this is your departing row and this is your pivot column. So this is what these two are very important to go to the next step. You have to be knowing your pivot column and you should be aware of the departing row. So now we'll be going to the next table. The next thing which we need to find out, what is the pivot element? Okay, what's the pivot element? So a pivot element is the one which coincides the departing row and the departing and the pivot column. So this is the pivot column. This is the departing row, which is the element that is intersecting, which is part of both, this and part of both this. That is this particular element, that is 5, becomes the pivot element because it is the element that is present in this also, that is present in the pivot column also, and even in the departing row. So the element present in the departing row and the pivot column would be that intersecting element which is present in both. That particular element will be the pivot element. So the pivot element is 5. You have to keep even this in consideration. This is very important. Pivot element in this particular thing is 5. See, now once when you have not got the optimal solution in this, we have to again prepare another table. The other table is this one. This table is called as the first iteration table. Okay, over here what we have to do is, it is same as this. The column headings would be same. That is basic variables x1, x2, x3, s1, s2, s3, bi. All these are going to be the same. Okay, so now I have prepared the same thing. That is, here the heading was basic variables, x1, x2, x3, s1, s2, s3, and bi. This is what I have prepared. This portion of the table and all these things you have to do only if you don't get the or this part of the table and these things, the departing and the pivot column, the departing row, bi divided by x, so all these things you have to do only when you're not getting an optimal solution. Okay, so initially you will be preparing this kind of table only. Here also, if you don't get the optimal solution, you will be preparing this particular column. You will have to be finding what is the departing row. We will have to find what is the pivot column. All this has to be done. Okay, but before that we need to find zj minus cj and see whether you will get optimal solution in this particular table. Okay, now we have arranged all these things. Now here there will be some changes. Okay, over here there will be some changes. Now in our initial simplex table, the one thing that we saw is we found out that this is the departing row. This entire row is called as the departing row. Okay, departing means what? The meaning of departing is someone is going away, something is leaving us. So that is exactly what is going to happen here. Since this is the departing row, your S1 is the element that is going to be departing. This S1 is the variable that will be departing. Since this is part of the departing row, S1 will be the element that will be departing. So now we will not write S1 in the new table. That is over here we are not going to write S1. Okay, since S1 is departing. Now what is the one which is entering? This pivot row. Okay, pivot row is also called as the entering row. Okay, this is the entering row. So this entering column. Okay, pivot column or the entering column. So what is entering in this? In the pivot column, what is the variable that you can see? That is x2. The pivot column, the variable you can see is x2. Pivot column, the variable you can see is x2. This x2 is what we are going to write over here. That x2 is what we are going to write over here. Okay, 1 second. So here you will be writing x2. You will be writing x2. Okay, why did we write s2 here? We wrote x2 as the first thing because this is the departing row. So s1 is what will be departing and this is the entering column. So x2 is what will be entering. So x2 enters as it is part of the pivot column or the entering column. So x2 will enter here. And since S1 is part of the departing row, S1 will be leaving. So S1 will go out of this and X2 will be entering. That's why I'm going to write X2 over here. And S2 and S3 will be the same. There will be no changes in S2 and S3. That is going to be the same. So here you are going to write, so here and here you will write S2 and S3. Okay, so now I wrote down S2 and S3. Okay, so here nothing will change. Okay, in this particular row everything is same. Everything will be same. Basic variable x1 to b1. Everything is same. Over here there will be some changes because this is the most important portion because this is the basic variables. This part is very important. Okay, so here what is entering, what is leaving matters a lot in this portion. So here it will be S1 will be departing as it is part of the departing row and X2 will be entering as it is part of the entering column or the pivot column. That's why this S1 is getting replaced by X2. Okay, so you will write it as X2, S2 and S3. X2, S2 and S3. I have not changed anything. Like everything is same. The only thing changes is X2. Now we need to calculate values over here. Okay, we need to calculate values over here. And this will be little confusing, but we can understand this easily. See, there is a different formula that we are going to use for this particular row and there is a different formula which we are going to use in this particular row. Formula for x2 is different, formula for s2 and s3 is same. Okay, so basically there are two formulas which we will be using. Now one thing to note is, this is your departing row, right? This is your departing row. So the departing row there is a different formula. Okay, for departing row there is a different formula. There is one more important thing over here, that is your pivot element. Your pivot element, that is 5. 5 is your pivot element, right? 5 is your pivot element. Okay, Since 5 is a pivot element and it is coming in this particular row, so whenever you're solving for the topmost column, that is for these values, you will just divide the previous value by 5. For this particular row, for the first row, what you will do is whatever values you have previously in that row divided by 5. The values previously in that row divided by 5. Let me show you this. Row 1. So this is for, I'm solving for row 1 separately. I'm solving this separately so that there is no confusion. Okay, for row 1 what is happening? Let us note down the elements. 4, 5, 4, 4, 5, 4, 1, 0, 0. 4, 5, 4, 1, 0, 0. 4, 5, 4, 1, 0, 0. These are the elements for row 1, right? We'll be dividing it with 5. We'll be dividing it with 5. Why are we dividing it with 5? Because it is part of the pivot column. We're dividing it with 5 because it's part of the pivot column. So this entire row, all the elements of this row will be divided by 5. All the elements of this row will be divided by 5. So in case of row 1, we'll do 4 by 5, 5 by 5, 4 by 5, 1 by 5, 0 by 5, 0 by 5. This is nothing but 0. So what will you get? You'll get 4 by 5, 5 by 5 is 1. Again you'll get 4 by 5, 1 by 5, 0, 0. I think one element is missing. 4, 5, 4, 4, 5, 4, 1, 0, 0. 4, 5, 4, 1, 0, 0. Okay, it's correct. Okay, that's totally 6. Okay, that's totally 6. So these are the values that you'll get. If I convert it to decimal form, let us not convert it right now, or you can convert it in decimal form so that you can easily place it in the table. Okay, so 4 by 5 is 0.8. 4 by 5 is 0.8. This is 1. This is again 0.8. 1 by 5 is 0.2. And the other things will be 0, 0. Okay, other things will be 0. And there's one more element which we just missed. In this particular row there is even 80. This we did not consider. We have to calculate only till here, because this portion is calculated only when we don't get the optimal solution. This becomes part of the table only when there is no optimal solution. So we'll be considering only till 80. So from 4 to 80 we have to consider. So 80 I have to take here. So 80. Let me take 80 over here. 80 divided by 5 is 16. So 16. So these are the values of your row 1. 0.8, 1, 0.8, 0.2, 0, 0, 16. That I will be writing down over here now. So this I am putting it over here, and these are the values. 0.8, 1, 0.8, 0.8, 1, 0.8, 0.2, 0, 0, 0.2, 0, 0, and 16. So that's how I got all these values. Okay. This is the way to calculate values for the departing row. Okay, calculation for values of departing row. Let me write down how I calculated it to avoid any further confusion. Okay, I'll just write it down. Departing row values. Value for departing row. Okay. Calculation for values. Calculations of values for the departing row. So why this particular formula? There are two ways of calculating. For departing row the calculation is different, and for the other rows the calculation will be different. That's why I have given this heading. Calculation of values for the departing row. Calculation will be whatever R1 values are there. I'm going to call this as R1. Okay, I'm going to call this particular row as R1. So let me write it as R1 divided by pivot element. Pivot element. This is how you calculate it. Okay, for each one, that is R1. In case of departing row, calculation will be R1 divided by the pivot element, which will be part of the pivot column. So that's how we got all these values which we have put over here. Now we are going to calculate for the row number 2, for the second row. Okay, now for calculation for the second row, first we have to note down the values of all these things. Let us note it down first. 544,010, 100. 544,010, 100. 544,010, 100. These are the values of S2. Okay, that is in the row 2. Okay, I got these values from this table. These are the values 544,010, 100. Okay, so these are the values that I have written over there. That value we have to subtract it. Okay, we have to subtract it with something. That something would be wait, let me just note down the S1 values. See, if you are taking S2, right? If you are taking S2, you will even require S1 values. So S1 values are 454,100, 454,100, 454,100, 454,100. Okay. See, we need to take the values here. We need to take the values of this particular row and not of this. Okay, we need to take the values of the x2 of the new table, not of the old table, of the new table. So the values will be 0.8. Let me put a comma so that there is no confusion. These are values of S2, and the values of row 1 is 0.8, 0.8, comma 0.8, comma 1, 0.8, 0.2, 1, 0.8, 0.8, 0.2, 0, 0, 16, 0, 0, 16. This is the values of new x1. Okay, this is the value of new x1. I have written new x1 because I have taken this from this particular table. Since I have taken it from this table, I will be writing it as new x1. From new x1, I have taken these values. Now, let us again go to our table number 1. That is our initial simplex table. Now, in this particular row, which element forms part of the pivot column? The element forming part of the pivot column is 4. The element forming part of pivot column is 4. So this 4 we need to note it down. Okay, element forming part of pivot column. Element forming part of pivot column is 4. Okay, this is part of pivot column. Element forming part of pivot column is 4. Okay, I am writing it as pivot. Okay, this is the element forming part of the pivot column. So now what you have to do next is you have to multiply this 4 with 0.8, with this new x1. You have to multiply these. When you multiply these, you will get certain values. Let us multiply first. 8 4s are 32, so you will get 3.2. 4 1s are 4. 8 4s are again 32, 3.2. 4 2s are 8. 4 into 0 0. 4 into 0 0. 16 4s are 64. How did I get these figures? I just multiplied new x1. I multiplied new x1 into 4. Okay, I multiplied new x1 into 4. I multiplied new x1 into 4. And what is 4? 4 is that element of row 2 which is part of the pivot column. 4 is that element of row 2 which is part of the pivot column. I just multiplied this, all the elements in this particular new x1 row with 4. That's how I got these values. Now the next thing which I have to do is subtraction. I'll have to subtract your S1. Let me just put a mark over there. Your S1. You will have to subtract your these values of row S2, and you will have to subtract, sorry, these. So now you have to subtract these values and these values. Okay, so we need to do 5 minus 3.2, we need to do 4 minus 4. That's what we need to do now. So now we need to do subtraction. 5 minus 3.2. 5 minus 3.2. How much is 5 minus 3.2? It is 1.8. 5 minus 3.2 is 1.8, comma, next element is 4 over here. Next element over here is 4. 4 minus 4 is 0. Next element is 4 over here and 3.2 over here. 4 minus 3.2. What is 4 minus 3.2? Again it is 0.8. Again it is 0.8. So I wrote it as 1. It's 0. Okay, 0.8, 0, 0.8, and the next is 0. The element over here is 0.8. 0 minus 0.8 is equal to minus 0.8. Next element here is 1. Over here it is 0. 1 minus 0 is equal to 1. So 1. Next element here is 0. Over here it is 0. 0 minus 0 is nothing but 0. Next element is 100. Here 64. 100 minus 64 is equal to 36. So now what we found over here, is the elements which will be part of this particular column. So these elements will be part of row 2 of your new table. How did we get this? We just subtracted whatever values we wrote here of S2 minus these values that we found by multiplying 4 with new x1. So it is basically S2. This is nothing but your S2 minus your new x1 into 4. This is nothing but S2 minus your new x1 into 4. That's how I got these values. Now I'll be putting down those values in the table, in this table. So now I'll just put down those figures over here, and this is 1.8, not 0.8. I calculated again, it's 1.8. This is 1.8, 0, 0.8, minus 0.8, 1, 0, 36. So that's how we got the values for the row number 2. That is for your new S2 row. These are the values. How did you find it? Through this particular formula that I have written in the edge of the page, at the corner of the page. This is how we found it. Now we have to do the same for row 3. Now we have to again find the similar method you applied here. That method you have to apply here and then find the values of all the elements of this row. Okay, so next what we will be doing is for row 3. So we have to take the values in the row number 3 so that you can find out the values for the new row 3. So values of old row 3 is 111001, 111001, 1, let me change the color, 1, 1, 1, 1, 0, 0, 0, 0, 1 and 20. Okay, 11100120. These are the values which I got from your table number 1. These are the values I got from your initial simplex table of the table number 1. That is 11100120 for row number 3. Okay. Now the next thing which you need to note down is these values. The values of the first row we need to note down. See, in case of row 2, also we noted down these values only, right? The new x1 values. The same new x1 values will be noted down in case of your row 3 also. There's no change. Okay, that is a new element which has come in. That is, let us say, like, we are giving respect to the new element that is come in. So every time you are just taking this new element in case of row 2, whether even if there are 4 more rows that you need to calculate, every time you will take the elements of the x2 row. Why are we taking the elements of this row? We are taking elements of this row because this is the new variable, which has entered. Since this is the new variable which has entered, we'll be considering this only. In case of calculation of whether it is this row or whether it is this row, whether it is new row 2 or whether it is new row 3. We'll be considering the values of this particular row. We'll be considering the values of this particular row also to solve it. So again, like how we did over here, same thing we'll be writing it down. So these are values of your S3, right? So next we need to write down these values. 0.81, 0.8, 0.2, 0, 0, 16. 0.81, 0.8, the same thing. I'm going to write it down. I'll put a comma here so that there's no confusion. Okay. So it is 0.8, comma 1, comma 0.8, comma 0.2, comma 0, comma 0, 16. This is of your new basic variable, that is your x1. Okay. It's of a new basic variable, new x1. I've named this row as new x1. I've named this row as new x1. I'm sorry, I'll take it as x2 first. There's no confusion since x2 is written over there. I took it as x1. This is nothing but x2, new x2. Similarly, here I just put it as new x2. Okay. So these values will be considering. Now we need to find out the element of row 3 which is part of the pivot column. In this particular case, that is 4, right? In this particular case, we have to find out which is that element which is part of row 3 and also part of the pivot column. Which is the element which comes in row 3 and it is also part of the pivot column. So these are the elements. These are the elements in row 3. In these elements, which is the element which is part of the pivot column? That is this particular element. That is 1 is that element of row 3 which is part of the pivot column. 1 is that element of row 3 which is part of the pivot column. So we'll be writing that down as, we're writing this as 1. So this is nothing but 1. Okay. Now, as we know, we have to multiply this with this. Okay, we need to, whatever values we are having over here, that is of a new x2, whatever values you are having, that we need to multiply with this 1, that is the element of row 3 which is part of pivot column 1. So you will be getting, I'll change the color, you will be getting 0. You'll be getting same numbers, that is 0.8 into 1, 0.8, 1 into 1, 1, 0.8 into 1 is 0.8, 0.2 into 1, 0.2, 0 into 1, 0, 0 into 1, 0, 16 into 1, 16. How we got this? This we got by multiplying your new x2 with 1. Okay, with 1. And what is 1? 1 is the element of row 3 which is part of the pivot column. That's how we got this. That's how we got these values. Now once we got these values, we need to subtract your S3 values. Okay, that is your S3 values, that is which is part of your initial table or row 3 initial table values, whatever we have. That values we need to subtract with this calculated values. Okay, so we need to subtract. Again, I'll change the color so that there is no confusion. 1 minus 0.8. 1 minus 0.8 is 0.2. 1 minus 1, 0. 1, again here, 1 minus 0, 1. Sorry, it is 0.8. 1 minus 0.8 is 0.2. 1 minus 0.8 is 0.2. Next is a 0 minus 0.2, that is minus 0.2. Then it is your 0 minus 0 0, after which it is, then you have 1 minus 0 which is 1, then you have 20 minus 16 which is 4. How did I get these values? We got these values by subtracting your S3 minus your new x2 into 1. Okay, that's how we got these values. Basically we subtracted all these values, all these values minus these values. That's how we got these values. And this is the row 3 values. So it is row 2, this is the row 3 values. Your row 3 value. Okay, so this becomes your row 3 value. So let me write it down in the table. We'll be writing the row 3 values over here, which we just found out. We'll be writing it down over here. So I'll just put the values that I found out here. Okay, so row 1 we found out over here. This is your row 1 calculation. This is your row 2 calculation, and this is your row 3 calculation. I found out the values and I put it in the table. I found out the values and I put it in this table. Now the next thing, the most important thing that you need to find out is what is Zj minus Cj. What is Zj minus Cj is the next thing that we need to figure out. So now we need to find out Zj and Cj values. We can directly do Zj minus Cj, or I'll calculate Zj and Cj separately and I'll show you. Let me just show you how Zj is done. Okay, Zj value. Okay, so now what is the coefficient of x2, coefficient of s2, s2, all these coefficients we have to write like how we have written over here. Okay, all this we are writing because we need it for our reference. Okay, that's why we are writing. So for that, let us go to our objective function. Let us refer to this, because from this only you will get that, right? This is a table. So okay, so now what we know for x2, it is 10,000. Okay, s2 is 10,000. 1 2 3 4. S2 10,000. S2 is 0, S3 is 0. Your x1 is 7,000. Okay, this is the same. 7,000, 10,000. I'll write it as 7k, so it is easy for me. 7k. This is 10k. Okay. 10k. This is your 8k. Zero, zero, zero. What I've written over here are the coefficients of these variables. Okay, coefficients. Coefficient of x2 is 10,000, so I wrote 10,000 here. Coefficient of s2 is 0, so I wrote 0 here. Coefficient of s3 is 0, so I wrote 0 here. Here 7,000. Coefficient of x1. Coefficient of x2 is 10,000. Coefficient of x3 is 8,000. Coefficient of s1, s2 and s3 are 0, 0, 0. That's why I wrote these values. So now we don't require this. Okay, so you got the values. Now once you got the values, you have to calculate the Zj. We need to calculate the Zj. Okay, so Zj will be equal to 10,000 into 0.8 plus 0 into 1.8 plus 0 into 0.2. That is your Zj. What I am talking about is only Zj. What I am talking about is only Zj. I will first calculate Zj values. Okay, Zj is what I am telling now. So Zj is equal to 10,000 into 0.8, that is 8,000, plus 0 into 1.8, which is 0, plus 0 into 0.2, which is 0. So here Zj you are going to get it as 8,000. So Zj is what? Here Zj is 8,000. So Zj is 8,000. I'll be putting it over here. Okay, this is your Zj. Similarly, we need to calculate values for this. Zj value for this column will be what? Zj value for this will be 10,000 into 1, 10,000. 10,000 into 1, 10,000, plus 0 into 0, 0, plus 0 into 0, 0. So your ZJ value is going to be 10,000. Yeah, it's going to be 10,000 itself. Okay, it's going to be 10,000. The ZJ value is 10,000. Okay, so this is ZJ value. Then the next value is 0.8 into 10,000, which is 8,000, plus 0 into 0.8, 0, plus 0 into 0.2, 0. So you will get 8,000 even here. So you are going to get 8,000 even here. Right? Similarly, you have to do for all these columns. That is 10,000 into 0.2. Here you are going to get 0, 0 itself. Okay, 10,000 into 0.2 is here 2,000. Is 2,000 plus 0 into this 0 plus 0 into this 0. So here you will get 2,000. The ZJ value is 2,000. The next value which you are going to get is for this particular column. 0 into 10,000, 0. 1 plus 1 into 0, 0. Plus 0 into 0, 0. So everything total is just 0. So here the value is 0. This is right now, 0. Next, 0 into 10,000, 0. Plus 0 into 0, 0. Plus 1 into 0, 0. So everything is just 0. Okay, that's how we got this. Okay, so now we have this column left. Same thing we'll be doing. 10,000 into 16, you'll get 1,60,000. 10,000 into 16, you'll get 1,60,000 plus 0 into 36 is 0 plus 0 into 4 is 0. 10,000 into 16 plus 0 into 36 plus 0 into 4. So answer will be, total will be 1,60,000. Your total is going to be 1,60,000. 1,60,000 will be your total. Okay, so that's how we got 1,60,000 over here. So all this which are calculated is the ZJ values. Okay, and what is the CJ values? CJ values are these values: 7,000, 10,000, 8,000, 0, 0, 0. These are your CJ values. If you want, I'll just write it down. CJ value is, this is 7,000. Better I put it in this form. 7,000. Okay. CJ value is 7,000. Here it is 10,000. Next value is 10,000. Next value 10,000. Next value is 8,000. Okay, 8,000. After this you have 0, 0, 0. How did I get the CJ values? CJ value is nothing but all these values which are written above. This is called your CJ. This is your CJ. C represents cost. So this is your CJ. CJ is 7,000 because x1's coefficient is 7,000 in the objective function. CJ for this is 10,000, 8,000. It is 0 here, so 0 here, 0 here, so 0 here, 0, 0. That's how I got these values. Now next what you have to do, ZJ minus CJ. That is 8,000 minus 7,000. 8,000 minus 7,000 is 1,000. 8,000 minus 7,000 is 1,000. So I'll write it down. I'll write this down as 1,000. This is the important part. This is 1,000. Next is 10,000 minus 10,000, 0. 8,000 minus 8,000, 0. 2,000 minus 0. 2,000 minus 0 is nothing but 2,000. 2,000 minus 0 is 2,000. Next is 0 minus 0, 0. 0 minus 0, 0. 0 minus 0, 0. Next what you have is, okay, here I didn't take your BI. Okay, so this doesn't have any coefficient, so we'll be taking it as 0. So 1,60,000 minus 0 is 1,60,000. So here, what we can see is there is no negative figures. There's nothing in negative. There's nothing in negative. That means we have got our optimal solution. Okay, there's nothing in negative. After we calculate Zj minus Cj, there is no negative value. Okay, there's no negative value. If there is no negative value when you calculate your Zj minus Cj, that means you got the optimal solution. So what is the solution that you have found? The solution that you have found is that x2 is equal to 16, s2 is equal to 36, s3 is equal to 4 is what you have found. So what we can conclude is, see here in this your second table, what you found out is, you found out that your x2 is equal to 16. x2 is equal to 16. That is what I have written here. x2 is equal to 16. x2 is equal to 16. Then we found out that your s2 is equal to 36 and your s3 is equal to 4. So s2 is 36, s3 is 4. s2 is 36, s3 is 4. Your s2 is 36, your s3 is 4. Okay, so you know x2, s2, s3, and whatever the remaining variables are there, their value will be 0. Okay, their value will be 0. So we know the values of these three, which we found the remaining variables will have the value 0. That's how we found this. Now the next thing which you have to do is find out what is your maximum profit. You need to find out your maximum profit. For that, let's go to the equation. Okay, so this is your objective function. So we need to just put the values in the objective function. That is 7,000 into x1 is 0. 7,000 into x1 is 0. Plus 10,000 into x2, that is 1,60,000. Plus 8,000 into x3 is 0. 0 into s1 will be 0. 0 s2 will be 0. 0 into s3 also will be 0. So this and all no need to calculate, because it is 0 into anything is 0. So 0 into s1 is 0. 0 into 36 0. 0 into 4 is 0. That means z1 is equal to rupees 1,60,000. z1 is equal to rupees 1,60,000. So this is your maximum profit. And also there was this constraint. Let me go to the previous slide. Okay, there was this constraint, if you remember, there is x1, x2, x3. These are the total cars that needs to be produced. The total car that needs to be produced is 16. How did you find that? Because x1 is 0, x2 is 16, x3 is 0. That means 16 is the number of cars that they are going to produce. Similarly, you can put everything in this equation and check for yourself what will be the values. The main part of this, the most difficult part of this, was to find the feasible solution that we found. Okay, I just summarize everything, because this is a very lengthy problem. This was the question. First we found out the objective function. That is this. Okay, after we are done with the objective function, we just wrote down the constraints. After writing down the constraints, we wrote in the non-negativity condition. After that we just wrote down everything. This is summarized. This is objective function, these are constraints, non-negativity condition. After that we have to do augmentation. Augmentation is all these inequalities that are there that we need to remove. We remove all the inequalities. Once we are done removing the inequalities, while removing we are also adding the slack variable. Okay, that is s1, s2, s3. These slack variables are added, and this becomes a non-negativity constraint. Okay, after that what you'll do is you have to find your initial basic feasible solution. Okay, initially assume that your s1 is equal to 80, s2 is equal to 100, s3 is equal to 20. This can be anything. I can assume even your x1 is equal to 80, x2 is equal to 100, x3 is equal to 20. You can assume anything. Okay, you can assume anything. That's up to you how you take this. Okay, so this is your initial basic feasible solution. So we have assumed 80, 100, 20 to be the initial basic feasible solution. Okay, after that we are going to proceed. Then we have to do the initial simplex table. You have to do the initial simplex table. Okay, that will be consider only these parts. This will not form part of it. Okay, you only this portion is what will be your initial simplex table. But since we didn't get the optimal solution, we have to prepare this portion. We have to prepare this portion. Okay, we prepared bi divided by x2 because we had to find the departing row, and this became the departing row. This became the pivot column. It is called as the entering column or the pivot column. This is called as the departing row or the pivot row, and this element which is coinciding in case of this departing row and the pivot column will be called as a pivot element. So pivot element becomes 1. Okay, so this is not optimal solution because these are negative. Okay, you should not have any negative. There should be no negative numerical in this particular column, that is Zj minus Tj. And this is your first iteration table. Over that, this is your x2. x2 becomes your variable that is entering. So x2 enters and s1 leaves. So s1 is telling bye and x2 is saying hi. So x2 is basically coming in and x1 is going out. And why did we choose this as the departing row? We chose this as the departing row because 16 was the least value. That's why this became the departing row. That's why s1 had to leave us. And that got replaced by the pivot column element, that is x2. Pivot column variable x2. Okay, so that's how we got x2 over here, and then we prepared this. To prepare this, over here I have written Zj separately, Cj separately. Over here I did not write. I have differentiated this so that you can understand the calculation. You can directly write Zj minus Cj. Just for the understanding purpose, I have written it as Zj separately, Cj separately. You can skip these things and directly go for this. To clear the calculation, you can directly write Zj minus Cj values. Okay, like how we have written over here. This for just the sake of calculation, I mentioned the Zj separately, Cj separately. Okay, in this what happened? In this we got all positive figures. We have got 0 and all the positive values. All are positive. If all are positive means you have got the optimal solution. That means x2 is equal to 16, s2 is equal to 36 and s3 is equal to 4 is the optimal solution. Now we got it. This is the way we calculated your values of row 1. Values of row 1 is all the elements of your row 1 in the table 1 divided by the pivot element. That's how we got the row 1 values. In case of row 2, we need to find out that particular element of row 2 which forms part of the pivot column, that is 4. First we need to find that out. After that, we have to write down all the row 2 elements. Then we need to write down all the elements that we found in the row 1. All the row 1 elements which we just calculated, these elements we need to write down over here. In the new table, we calculated row 1. Just now we calculated the row 1 values in the new table. These values we need to write down. And these values have to be multiplied by this 4. And when you do that, you get this new calculated values. So what you need to do? We have to subtract these figures minus these figures, and when you do that, you get the row 2 values, which is this. Okay, and that comes in the row 2. Similarly, you will do for row 3 also. Okay, you'll find out that element of row 3 which is part of the pivot column, that is 1. So basically, I've written down all the row 3 elements, and then what you've written down? Then you've written down the same thing. You have written down your row 1 calculation, initially. Okay, that particular elements you have written down over here. Then what you have to do? You have to multiply these elements. Okay, these elements you have to multiply with 1, and then you got this element, and then you have to subtract your x3 minus your new x2, your new x2. And when you do that, you will get these elements of row 3. After that, this is what is your solution. This is a feasible solution, and this is your maximum Z. We just have put the values in it and calculated. And similarly, we can even calculate the number of cars to be produced, that is only 16 cars. That is model B, 16 cars is what I want to produce. Other cars are not going to produce. That's what we found out. Here we cannot use graphical method. We cannot use graphical method over here because in this graphical method cannot be used. The reason is that there in graphical method, right, you have only two elements. There's x1, x2. That's all. There's place for only for two variables. There is no place for three variables. Whereas in this question, three variables are considered. So you cannot use a graphical method to solve it. That's why we have to use a simplex method to solve this question. Thank you so much. Please do like and subscribe the video. Thank you.